Yeah. Hi guys, hi everyone. Good morning. Yes, good morning everyone.
Good morning, people.
All right. Do you guys have any questions in the last session? Yes, anybody have any questions in the last session? All right. So let us go to the next part now. So this is what we have discussed, right, in the last session. This is what we have completed in the last session. Uh, and in the end, we have started with treating missing values from rows or in rows. Now we need to either delete or impute missing values. What do you mean by imputation? Can anybody tell me what is imputation?
When we replace the missing values with mean, median, or mode, we call it is called as imputation.
Very good, excellent. So you either replace your missing value, don't delete it, right? So you replace that missing value with mean, it could be median, or it could be mode. We'll see these scenarios where we generally fill missing value with mean, median, and mode. That is what we are going to see in this session. So first, let us see if there are any rows having a significant number of missing values. If so, we can drop these rows and then take a decision to delete or impute the rest, right? Now, after dropping these three columns, we have 18 columns to work with. We have initially we have dropped the three columns from our dataset, which had a lot of missing values, more than 50%. So we are left with only 18 columns now. Yes or no? We have 18 columns. Now, uh, 18 columns is what we have. Okay. So, how do you check missing values in a rows? Column, we know we have used axis equals to 0. Now, uh, now you should write down df dot is null dot sum. An axis is equals to 1, you'll write, and it is greater than 5, suppose. So if your null values is greater than 5 for that particular row, which means 1, 2, 3, you can count from this place. 1, 2, 3, 4, 5. And if you just scroll to the right hand side, so you can account 1, 2, 3, 4, 5, 6. So if it is greater than 5, the null value is greater than 5. Uh, what we are going to do is we are going to remove that particular thing. So we are keeping threshold as 5, right? Now, if you notice, if you notice an interesting pattern, that is many rows have multiple columns missing. Many rows has multiple columns missing. Since each row represents a house, each row represents a house, it indicates that there are houses, that is observation, whose majority, whose majority, excuse me, whose majority data has either not been collected or it is unavailable. It is unavailable, right? Such observations unlikely to continue or contribute, unlikely to contribute to prediction of prices, and thus we can remove the rows with, say, more than 5 missing values. We can remove the rows with more than 5 missing values. So what we'll do is we'll count the number of rows having more than 5 missing values. So for that, we'll use length function, df.index, alien, df of df dot is null dot sum axis is equals to 1 and should be greater than 5 dot index. So what this will do is, we already have done this part, right? We already have done this part. We are finding length of that index. So total, we are counting number of rows having greater than 5 missing values. If you write on df.index, and if you just write on length of df.index, you'll get total number of rows, right? So you have 23,547. Out of that rows, we are putting a condition. The condition is it should be greater than 5. Null value should be greater than 5. So we have 4,278 rows out of this 23,547. Now we'll calculate the percentage. Let's calculate the percentage. Let's calculate the percentage. So length of same thing, we can take this, which will give us the 4278, right? This value will give you 4278. It will divide this by length of df.index, basically. Length of df.index. And we are going to multiply that with 100 to get the percentage. To get this is in percentage. So we have 18.167 percentage of missing values or of rows which has missing values greater than 5. Which has missing values greater than 5. Right? So what we'll do is we'll retain the rows having less than or equals to 5 null values. So df is equals to df dot is null dot sum, and axis is equals to 1, which should be less than or equals to 5. Right? We are retaining the rows having less than or equals to 5 null value. So at max 5 should be uh, permissible values, right? 5 missing values in a row in totality is allowed for us. We are having that condition. So we'll round this again. Round what it will do is, suppose if I round this particular thing, right? And I round it to 2 decimal places. So it will be 2 decimal places, right? Similarly, this is also something which we'll do. Same thing, only condition is exactly opposite. Exactly opposite to what we are actually looking out for. So less than or equals to 5. Okay, just a minute. Or suppose if I want column wise, so I'll write down round 100 into 100 of what? df dot is null dot sum, and I'm going to divide this with length of df dot index. So no percentage over here. We'll get a column wise, sorry, row wise summary of your data, right? Actually, column wise we'll get in this column suburb, uh, how many null values which are there. So we have 0. In price, uh, your missing values are 21.7%, right? So what we are going to do is whenever, if your missing value is less than or equals to 5, we are only considering that data frame. We are removing or we are neglecting the missing value if it is greater than 5 or if it is not satisfying this condition. And then we are just looking at the summary now, right? Summary of your column. So here up till this point, just a minute. Up till this point, we are done with the rows, dealing with the rows missing values, right? Now we are just checking, having a look at the missing values in all the columns. So price, I can see 21.71 percentage, and rest of the things are okay for us. So we are at the position to, we have deal with the missing values and which is less than 22%, we can say, and that can be considerable, right? So if you notice that now we have removed most of the rows where multiple columns, that is bedroom, and land size, that were missing. That were missing. So now we still have about 21% missing values in the column price and 9% in my land size. And since my price, it still contains a lot of missing values, a lot of missing data, and imputing 21% values of a variable you want to predict, it will introduce a heavy bias. And at this point of time, I only told you that bias is something which is important in machine learning. So we are going to learn that. But consider bias as the error. So it will introduce a heavy error. That's all. In simple word, bias is error. So it's a bad idea. It's a bad idea to impute those values, right? So what we'll do is let's remove the missing rows in price as well. And notice that you can use np dot nan or isnan df of column to filter out the corresponding rows and use this one to discard values satisfying the condition. To discard the value which is satisfying this condition. So I'm going to remove NaN price rows. So I'll write down df is equals to df of not equals to np dot is nan df of price. So what is this? This is negation. This operator is known as negation, right? So basically, wherever is it means not equals to, basically wherever uh, this value np dot is nan df of price, what this will give you? It is going to give you the missing values in the price column, right? Conditional check. And if you write a not, if you write a not, negation, this one. So wherever it is true, it is getting false over there. It is just inverting the records. Can you see this? See, first row 0 is true and 3 is true, right? Now if you do this, 0 is false and 3 is false, right? So basically, it is inverting the records. Inverting the records, right? Now if you just check this, it will only consider those values. It is only considering those values wherever there is a false. Can you see this? But to select false, uh, we cannot select false rows by using that df. So what we are doing is we are inverting that. So here false means what? What do you mean by false for this criteria? If you write down this, let's say true means you are only going to get that records wherever there's a null values in the price column. Can you see this? If I write down this, I'm getting all the records for null values in price column, right? But if I just invert this, if I just invert this, can you see this? I'm getting all the non-null records from the price column. Non-null, right? If I just remove those, so I think this is clear now. Can I get confirmation? Okay, quick confirmation of this. Yes, everyone. Okay, excellent. Now I'm going to increase my pace a little because we still have to cover a lot many things, and I always want to give more than extra related to whatever they have given in the syllabus. So you guys have to deal with this. Basically, I'm going to share more than required for our syllabus. Basically, there will be hands-on session, case studies, and more practical sessions. But you guys have to deal with. You guys have to respond quickly, right? Even if it is not understanding, you have to take efforts from your end as well, so that I can deliver maximum possible, which is important, and which is not there in our syllabus, right? So there only we will be able to be in a position to cover extra to whatever it is there in the syllabus, right? So I need little help from your side as well. Okay, so uh, after removing the null values in this price column, now we can check all the null values for the columns, which we have done over here. So I can take this and I'm going to paste it over here. So can you see now the price column was the critical column for us because it has 22% missing values. We are literally removing all of them because that was critical. Now we are only left with maximum 10% of missing values, which is, let's see if it is good or not, right? Now again, there is some little caveat of what we are going to do is, so land size is 10%, we'll again remove that, right? Df of land size, missing values, and I'm going to describe that. So I can see count is this, mean is this, standard deviation is this, minimum percent is this. Uh, so 0 to 176 is 176. 440 to 176 is 440 minus 176.5. and last is okay. Last is problematic. Can you see here? What I'm doing is I'm just taking ranges of quartiles. What is quartile? Anyway, that is there in your statistics, but I'll explain that. Suppose if I just take my data, only this column, land size column, and if I just divide that into four equal parts, it's comprised of 25% each. 25, 25, 25, 25. So I'm going to get the quartiles. So this is your Q1, this is going to be Q2, this is going to be Q3, and this is going to be Q4. This is known as median Q2. So median value is, which is 50%, which is 440, that is fine. Now we are going to check the range. 176 is the entire range for first quartile. Second quartile is nothing but 440 minus 176, that is somewhere around 26 plus 40, it is 286, 186. And this is again somewhere around 200. So that is not something which is huge. But if you check last quartile, so you have maximum data, which is 430014 minus 651. So it is near about 43,000 records, 43,263. This record is, we have maximum bunch of values in our higher quartile, right? This quartile. So we need to inspect this column because maximum value which is there present in uh, your maximum quartile or higher quartile. So if you notice, the is zero, minimum is zero, uh, maximum is 433,014, and the mean is 558, and median is 50%, which is 440, right? So there is a significant variation in the 25th and the 75th percentile as well. That is 176 to 651, right? Thus, imputing this with mean slash median seems quite biased, and so we should remove the null values. Right? As I've discussed this graphically, so there's significant variation in the 25th and 70th percentile as well. Uh, so we will remove the null values. Maximum null values could be in your last quartile. So again, we'll just take that condition which we have discussed. np dot is nan df of land size, and we'll round this 100 into df dot is null dot sum divided by length of df dot index comma 2, right? So now you can see 0.16 maximum is 0.46% missing values in all of your data. So we can say we have reduced the null values significantly. So only the variables bathroom, car, latitude, and longitude have a small number of missing values, most likely the same rows will have latitude and longitude missing, right? So we have reduced null values significantly now. Only the variables bathroom, car, latitude, and longitude have a small number of missing values. Most likely the same rows will have latitude and longitude missing over there. So we'll just have a look at rows having latitude and longitude missing. Df.np.is nan df of latitude, df of latitude. If I run this for latitude column, for latitude column, we are selecting latitude and latitude column basically, which is we are selecting all the records in for latitude column, which is missing, right? So all the records in latitude are missing over here. We are just selecting that, and surprisingly, we are getting a bonus. If you see this for all the records out there, all the missing records for latitude, we have longitude is also missing. So we have a bonus, right? For all the latitude like records, longitude is also missing, right? So as expected, as expected, the same rows having the same rows have latitude and longitude missing. Let's look at the summary stats of this. So df.loc for all the rows out there, latitude and longitude. Longitude. Or is it longitude? That's similar. The longitude, yeah. Longitude. Might be pronunciation is longitude. I'm not sure. So we are selecting all the records. I mean, we are just having a descriptive statistics of these two columns, latitude and longitude, right? Longitude. So count is this, mean is this, standard deviation is this. So a good way to estimate a spread of your data is to have is to look at the difference between the mean and median. Mean and median. If it is satisfactory, then you can say it is not a good spread. If the difference is quite high, let's say here it is only 144 minus 145. So basically it is 145 only. So the difference is very less, right? Again, here also 37.802 minus 37.92. This is also very less significant, very less, right? So the distribution of both the longitude and latitude is very fine. It is good. There's no any problem for us, right? If it would have been a high difference between mean and median for both column, then there would be a trouble for us. So it quite narrow. A good way to estimate the spread of data is to look at the between difference between mean and the median. The difference, the lower the difference, the better it is, right? And the variation from the 25th to 75th percentile, that is quite small in this case, right? Thus, let us impute the missing values by the mean value of latitude and longitude respectively. So I'm going to impute latitude and longitude by mean values. So df.loc np dot is nan df of latitude should be greater than. Okay, I'll explain this. What we are doing is we are imputing latitude and longitude by mean values. So that is imputation for us, right? So wherever there is a null values for latitude column, for that latitude record, this is your syntax. You have to remember this. We have to replace that with latitude, latitude mean, right? We have to replace that with latitude mean. Second, df.loc np dot is nan df of longitude, comma longitude uh, here round bracket should be there, square bracket should be there, df of longitude dot mean, right? And I'm going to round this under it into df dot is null dot sum divided by length of df dot index, comma 2, right? So 0.46, 0.01, and for latitude and longitude, there are no null record because we have imputed that with mean values, right? So wherever there is a missing value, we have just filled that particular value with the mean value, right? So all of the missing values for the latitude and longitude is cleared, right? Now we only have bathroom and car with 0.01 and 0.46 null values respectively. Since these are very less, bathroom and car with 0.01% and 0.46% NaNs respectively. Since these are very small number of rows, it does not really matter whether you delete or impute. However, however, let's have a look at the distribution. Let's have a look at the distribution. So I'm going to write down df.loc for all the records for bathroom and for car. I'm going to describe. So again, the difference between mean and median is significant over here. Uh, these two are integer type variable and thus have 0, 1, 2 values, and you cannot impute NANs by the mean or median. Let's say for bathroom and car in your record, do you have some in float value? Do you have some float values? You don't have float values, no? So can we impute with mean 1.53, 1.61 for this records? Can we impute this, guys?
No, sir.
Why we cannot impute?
Because the values are an integer in mean, sir. If we impute that bathroom cannot be 1.5, it has to be a whole number, right? So that's why we cannot impute the values with mean.
Right, right. Or that is what it is, right? Bathroom be 1.63 value? Can we have the value 1.63 in bathroom? We cannot have, no? Since 1.53 bathrooms does not make any sense, right? Does not make any sense. So, thus you need to impute that with mode, right? So that is where the situation is. We need to impute them by the mode, and the most common occurring value, that is your mode. So what we'll do is, we'll first of all, uh, as this is integer, we need to convert the data type of this columns into uh, different data type. So I'm going to convert to type category, category data type. And how do we convert? This is also very important. You should remember this. Suppose if you want to convert any column into any column data type into another data type, so that is what you should write. So suppose if it would have been integer and I want to convert that into float, so I'll write down as type to float. Now here I wanted to convert this integer value, or rather it is float value, into category. So I'll write on dot as type category, right? And I'm going to displaying frequencies of each category. So df of car dot value underscore counts, open and close bracket. So the frequency we are getting, right, for two car, it is 5606. People who is having one car, the total amount, total frequency is 5515. Zero car this, three car is this, 4, 5, 6, 8, 9, 10, and something like that, right? So the most common value is over here. It is most common value for car is 2, right? But data type is integer. So let us impute the null values by that. So let us impute null values by that. So I'm going to impute the NAN's null value by 2.0. So df.loc, fetching the records pd.is null for df of car, uh, comma, for that car column, we are just fetching that. If it is null, fetching that with or replacing that with 2 value. And then you can use the round function of 100 into df dot is null, right? This is something which we have used multiple times, right? So length of df dot index, we'll round this with 2 decimal places. So car, we are imputing that with the uh, we are imputing that with 2, Just a minute. This is fine. If I run this car, it's 0.46. No, it should be 0 now. Dm.loc. If I just restart and run all this, let's check. Here we are imputing that with the 2, or it should be 2.0. Let us no. Okay, got it. Thank you. Car should be small, right? Right. Can you see now? Here it is 0, right? So similarly for a bathroom, you can do this. That is what I can give it as homework. For a bathroom, you can do this. Convert to type, category, and df of bathroom, you'll write is equals to df of bathroom dot case type, and it should be category, right? And I'm going to display frequencies of each category, df of bathroom dot value underscore counts, right? And then you can replace that bathroom with 1, same thing. Now, is it clear, guys, for you? Anybody have any questions here? So this is very tedious task, right? It should be replaced with 1. So what has happened? It should be replaced with 1, right? 1.0. And now it is not there for another column, right? Okay, car it is 2. I think we have created another car column. All right. Now we are at the end of this missing values part, dealing with missing values. Now we have a data frame. We have a data frame with no missing values. Now let us finally look at how many rows apart from 3 columns we have lost in the process. Originally, we had 23,547 records, right? Now, out of 23,547 records, only 13,603 records are remaining. So fractions of rows lost are length of div dot index divided by this 23,547. So 57.7. So we have lost near about 1 minus 0.57. We have lost about 42% of the records of observations in just cleaning the data out, cleaning the missing values, right? Now, anybody have any questions till now? You can ask in this cleaning data module. If you have any questions, you can ask. Yes, guys, is it clear? Okay, now there's one interesting read. This is out of syllabus, but I would like to give you this thing so that you will understand it, why generally the missing values occur, right? So how you treat missing values should ideally depend upon an understanding of why missing values occur. The reasons are classified into categories such as missing completely, at random, missing at random, missingness that depends on the missing value itself, etc. Right? Will not discuss why missing values occur because that is not covered in our syllabus. But I'll share one article with you, which is by Columbia University. You can read that PDF, right? So just give me a minute. Okay, so the article is Hmm. How can I share this link? But think just check, guys. Is it accessible to you? Can you just read this? Yes.
Yes, Vipul. It is readable. We can read.
Can you just download that? Just check if it is allowed or not. Well, I think if I just close, no, it will not. You guys will not be able to access that. So I will request to download this particularly. Yes, Karthik, just check. Are you able to download that? Perfect, perfect. So just make sure you download that because if I just close, you guys will not be able to access that. All right. Now I think we are good to go with the next module, which is our will we can start with SQL. We can start with SQL, but as we are in the intermediate level of uh, pandas and data analysis, so it would be better if we just start in the flow. If we start this module EDA, so that should be like entire Python will be finished, and then new module we can start. So you can suggest me what should we do. Based on the votes, we'll go with the next part, right? I'll suggest to go with the EDA because already you guys are knowing, you guys already familiar with the all of the techniques to deal with the missing values and basic functionalities of Pandas. So EDA will not be a big task for you at this point of time. But let's say if you go for SQL now, and then if we go with then we if we go with the ED after some days, so you'll able to you will not be able to be in this zone in which you are there right now, right? So you can let me know in the chat. I will go with the votes. Anyway, is fine for me. That is not a problem. Or if you are, if you want to go to the next module, like let's say Python is enough at this point of time, we'll go with the SQL. That's not a problem. Okay. What about class and object? Okay, we can go with the class and object then. That is remaining. No? Thanks for informing. I okay, here only we can go with the class and objects then. All right. So, all right. So, see, basically, Python is object-oriented programming language, right? Python is an object-oriented programming language. So, what do we mean by this? We'll just see this. What is object-oriented programming language? We are going to see that. How to format the particular column, example, date and time format or phone number. Okay, let me have a look at the syllabus, then we can discuss. Just a minute. Is it there in our syllabus? Okay. Um, in classes, class and object. That is only remaining, right? Okay. Anyway, date and time is something. How do we deal with the date time format? Uh, we are going to discuss that in EDA part. So we are going to take out the data basically, and the data type of some of the column will be date time. So for that, we have pd.datetime function, which we are going to discuss at that point. So pd dot date time, this one, right? It covers all the date and time related functions and how to deal with that. So we'll discuss that at that point of time, right? Okay. Even though this class and object is not important, I personally think it's not important for data scientists and data analyst kind of people, but still we'll discuss. See, Python is an object-oriented programming language. Almost everything in Python, almost everything in Python is an object. Everything in Python is an object, right? With its properties and methods. A class is like an object constructor or a blueprint for creating objects, right? So we'll create a class. To create a class, to create a class, we use the keyword class, right? For example, I am interested to create a class named, let's say it can be any name, but let us give it as my class with a property named X, right? So I'm creating class, my class, and X is equals to 5. Now, uh, we can use the class named my class, which we have created, right? My class, to create objects, to create objects. So I am uh, interested to create an object named P1 and print the value of X. So I'll write on P1 is equals to my class. P1 is equals to my class, and I'm going to print P1 dot X. So which is 5. So the example above, which we have seen, are classes and objects in their simplest form, and they are not really useful in real life applications. To understand the meaning of classes, we have to understand the built-in, that is underscore underscore init method or function, and all classes have a function called double underscore init, open and close bracket, comma, which is always executed when the class is being initiated. So we use the double underscore init function to assign values to object properties or other operations that are necessary to do when the object is being created, right? So this is important. This is little important. Not even if you don't know init function, you can write down code. Uh, you can build machine learning models, right? So we'll create a class named person. We'll use the double underscore init function to assign values for name and age, right? So class person define double underscore init double underscore self name and age. I'm going to pass this. So it's just like creating a function, which we have discussed, right? Now self dot name is the name that you're going to pass. self dot age is the age that we are going to pass, and p1 would be equals to person, that is John, comma 36, and I'm going to print uh, p1 dot name. I'm going to print p1 dot age. Okay. What is wrong here? Spoons, myself, dot name. Is it indentation error or what? Okay. Let me restart first of all. It's not space after df. It's a okay, space after df is it right? So basically it was syntax error. So see, this is your function. Like we have discussed how do we create a function, right? We have created function. Just like that, we are creating another. We are using. We are creating a class named person using underscore init function to assign values for name and age. Right here, you should note the underscore init function is called automatically every time the class is being used to create a new object, right? So the underscore str function, the double underscore str function controls what should be written when the class object is represented as a string if the underscore str function is not set. The string representation of the object is returned, right? So here we'll take an example, the string representation of an object without the underscore str function. We'll define a class named capital person, this capital P, define underscore init, double underscore self, comma name, comma age, self dot name is equals to name, self dot age is equals to age, and p1 is equals to capital person John, comma 36, and I'm going to print this p1. Right now, same thing we'll see string representation of an object with your uh, uh, with your string function. not without. So we can take this out, same thing. Here we'll define underscore underscore str underscore underscore self return f string self dot name and self dot age. And this should be nothing, right? And then P1 person John is this thing. So John 36 is being called, right? See, this is more profoundly used for a developer. For I mean, developer role, you should be having an idea about that. I can go in deep if you guys want me to discuss this. I can discuss object method as well. But again, I suggest you guys to not go into much depth for this, right? Objects can also contain methods, and methods in objects are functions that belong to the object. So we can create a method in the person class, which we have discussed. So I'm going to insert a function that prints a greeting, and execute it on the P1 object. So class, okay, class person, which we have done, we can take that here, okay, and here we'll create one more function, define df my function. In that we can pass self, and I'm going to print hello, my name is space plus self dot name. And print p1 dot my underscore function, which we have created. So hello, my name is John, right? You can write down self dot age as well here to get the age, right? I think we can we should not discuss with the next part, which is how to modify object properties, how do we use self parameter, how do we delete object properties, right? Pass statement. Right, I think is it clear now, everyone? Do you guys have any questions in this? How do we create a class? How do we create an object? Yes, fine. Uh, let's take a break now for 10 minutes. It's 10:18, right? So we'll have break till 10:28. And after the break, we'll start with the SQL. Let us start with the SQL to, change our focus a little bit from Python to SQL. SQL as compared to Python is simple. So you guys will not feel weight of learning. So basically you can relax for 2 sessions at least for SQL, and then we'll start with the EDA again, right? So this kind of this will be a basic relax sessions on SQL now. Uh, if you want syllabus, we can write down that syllabus for SQL, and then we'll have a break, right? So in our uh, uh, syllabus, which is shared by them, they have introduced data modeling, normalization, star schema, ACID transaction, select, insert, update, delete, join operations, window functions, rank, dense rank, row number, data types, variables, and constant conditional structures. If case, go to null, integrating Python with SQL, which integrating Python with SQL we have discussed, right? Uh, so we'll discuss this, yes. Apart from this, we'll discuss some important case studies, and I'll give you one assignment which you need to solve, right? So what we'll do is we'll have a break now. It's 10:20. Let's have a break, a quick break of 5 minutes. Sorry, 10 minutes. Uh, we'll meet somewhere around 10:31. Right? If you have any questions, you can let me know in the chat so that I can discuss that after the break. Okay. All right. So let us start with the basics of SQL, right? So what we are going to do is before actually starting with the SQL, we'll just have discussion on database and data warehouse first, and then we'll start with the basics of SQL commands, right? Because if you guys have an idea about why SQL is needed or what is data warehouse, what is database, then only you'll be able to relate these things, right? So for that reason, we are not going to start with directly SQL. We'll start with the basics of SQL and database and data warehouse thing, right? Now, just a minute. Just give me a minute. All right. So, so far you have learned how to perform basic data analysis using Python and Excel, right? Not Excel. Excel we have not discussed. Only Python. Uh, you have learned. You have also learned that it is risky to manage data from different files that may lead to inconsistency, right? An organization cannot track its business activities efficiently by maintaining a large number of files. Hence, databases are created. So, databases are used to access and manage data efficiently. The software, which is known as DBMS, its full form is Database Management System, DBMS, is widely used in the industry to analyze data easily, right? Now, in this module, you'll be introduced to the basic concepts of uh, data warehouse, basic concepts of data warehouse, star schema, OLAP, which is online analytical processing, OLTP, which is online transactional processing. We'll select SATL, which is select extraction transformation and loading, right? And we'll see constraints and we'll see ERD, that is entity relationship diagram, right? Now, we are going to discuss what is data warehouse. Now, think of yourself as a data analyst working for a company that has following three departments, right? We have marketing department with us, we have sales, and we have finance. Now, let us assume that each department maintain its separate database. Let's say this is database 1, this is database 2, this is database 3, right? And this could lead to a situation wherein each department has its own version of the facts. We'll discuss that after some time, what is facts. And for a question such as what is the total revenue of the last quarter? What is the total revenue of the last quarter? So every department might have different answer, right? This is because each department draws information from the different database, database 1, database 2, database 3. This is where A data warehouse can prove to be useful. It can help with creating single version of truth and facts. Don't worry about this. We are going to discuss that. But let's just allow me some more time to discuss this in more detailed fashion once uh, that topic arrives, right? Now, uh, a data warehouse would thus be the central repository of data of the entire enterprises. It's a central repository of the data of the entire uh, enterprise, right? Now, you will learn uh, what data warehouse is, and how it is useful for companies to carrying out data analytics. You'll also learn OLAP, Online Analytical Processing System, which is used to extract business relevant information and perform analysis on data stored in the data warehouses. Right? So we are going to discuss that. So uh, yes, we can have a broader definition of what data warehouse is. So if somebody asks you what is data warehouse, you should add this definition, which will be very impressive for your. I mean, you can use this definition for your interview, which will be very good help for you. So first, it is subject oriented. Subject oriented. So a data warehouse should contain information about a few well-defined subjects rather than enterprise. Second, it is integrated repository. Third, it is non-volatile in nature. Non-volatile in nature. And fourth definition, it could go like, it should be time variant. It should be time variant. So data warehouse is a collection of data. It should have following properties. Let us discuss these properties one by one now. So first is subject oriented. So this definition is given by Bill Inman. Uh, he gave a second information definition of what data warehouse is. So data warehouse is a subject-oriented, non-volatile, subject-oriented, integrated, non-volatile, and time-variant collection of data in support of management decisions. I would now draw your attention to the four important keywords included in this definition and discuss each one in depth. So firstly, data warehouse is subject-oriented in nature. What we mean is that data warehouse includes the collection of data pertaining to a handful of well-defined subjects rather than including the whole gamut of information of the entire enterprise. Just look at this, just look at it in this way. We have assembled the data sets for investment analysis, right? We have assembled a data for investment analysis. So, suppose we have company's data set and we have investment data set. Investment data. In companies, we can have anything related to company, permanent link. We can have organization. We can have fame. We can have company name. We can have company URL, company home page URL, and we can have the website HTTPS, something like that, right? When it comes to investor point of view, we can have same thing: investor permalink, investor name, organization, DT, capital, partners. We have investor name. We have DT, capital, partners. We have anything related to industry country code, and we can have something like that, right? So this could be our data, right? Now, let's say we are interested to do the analysis of this investment. We have collected data from nascom.com, which is a platform where uh, uh, basically we get it's a portal, online portal. We get where startups can log in and upload their information. I'll just show you what is nascom is. Startup can log in and they can, this is their platform. So startup can log in, they upload their information applying for funding. If my funding is if it is approved, if your startup funding is it is approved, you will be having a list of investors and their amount and something like that, right? So it is useful for startups. So what from that uh, what we can say website, we just have gather the data and upload. We got a data related to employees information, their past product. We can clearly see information to many subjects, right? So according to Bill Inman or Inman, I don't remember the name exactly, he has given this definition. So it is subject oriented in nature, right? So this is not good for us, right? We have a data set. It includes all the application details of the buyer data, of all the employees information about their past product and so on. Then clearly our data store contains information about many subjects, right? So that is not a good thing for our analysis. Instead of that, since we are interested in sector wise and geographical wise analysis of our investment, we should include only data pertaining to this subjects in our data warehouse, right? So it should not be scattered. It should be segment wise or subject wise data. So data warehouse should have subject oriented data. Second keyword that we have, let us move now to the second keyword from our definition of what data warehouse is. We have integrated repository. So the data warehouse is an integrated repository. It is worth noting that information pertaining to a subject may actually be coming from many different systems. In our own cases, there could be one portal where startup application data is collected. There might be another data set, application data. There might be another database that contains industry standard information. There might be yet another database that contains information about the investors, right? Investor database. And investor about, there might be another data set in which we have information about the investors, right? So what we are saying is that when building a data warehouse, we must bring together all information from this multiple sources into a single integrated data warehouse repository hosted in a single location, right? It should be single integrated repository hosted in a single location. Now let us move towards the third definition in our third keyword in our definition, that is non-volatile. So data warehouse is non-volatile in nature. Volatility indicates changes in the context of data warehouse. What we want to say is that data is a repository that will never change. This part of definition gains enormous significance. It should never change. In the face of stringent compliance standards uh, act, as we call it, we needless to say that non-volatility also prevents data from being erased or deleted, right? What is non-volatility? We prevent our data being erased or deleted. We prevent our data from being erased or deleted. The non-volatility nature of a data warehouse is important for giving legitimacy and credibility to the analysis being done on data in the context of our investment analysis. What we are saying is we cannot keep modifying the figures. Let's say you have investment data. And what do we mean by volatilities, non-volatilities? Let's say company name is, let's say, ABC organization. The date of their investment is, let's say, 15th uh, June. Then we have location or country for their organization. We have country code. It should be US or something like that. And we have amount. It is $15,000, suppose. Right? Then again, same company has invested in that organization on 15th December. So can we go and remove this, modify this and just add the value? It should not be like that, right? It should be non-volatile. Once it is added, you cannot uh, erase that, right? So if it is allowed, if the modification is allowed, our whole analysis will become questionable, right? Yes or no? So we needless to say, non-volatility also prevents data from being erased or deleted. The non-volatile nature of a data warehouse is important for giving legitimacy and credibility to the analysis being done on the data, right? In the context of our investment analysis, as we have discussed, what we are saying is we cannot keep modifying the figures of exact investment that have been made by a given investor. If that is allowed, our whole analysis will become questionable, right? And that brings up the seemingly contradicting requirement that the data warehouse is time variant. Here, the fourth keyword is time variant. It means it is referring to the importance of historical data for our analysis. The time variant nature of data helps us to build adaptive analytics that reflects newer understanding and inferences based on newer data. I would like to add that time variance does not contradict the non-volatility requirement. Non-volatility, what it does is it prevents existing data from being changed without any legitimate reason. So there's no any problem with the newer data being added. You can add new data and you can, it should be time variant. Let's say same company has done investment on 15th May. Country code is US1, something like that. Again, this time it is $50,000, right? So this time variance does not contradict with non-volatility requirement. It only prevents existing data from being changed without any legitimate reason. And there's no any problem with newer data being added to build historical information. Just think about it, right? So in our investment data, we have ABC Capital, who invested $15,000 in our organization, and we are not allowed to fudge that number or change it. So that is non-volatility for us, right? Same ABC organization came and did investment on, let's say, 15th July. So we are not allowed to change the first record. So we are not allowed to fudge that number or change it. So that is non-volatility for you. On the other hand, same investor had invested in the same company or some other company sometime later. So we are allowed to add data to build historical information about that investor, right? So there you have a full definition of a data warehouse. We saw four important pillar of definition, which is subject oriented, integrated, non-volatile, and time variance. Data warehouse are important for organization because if you have to do analysis of data from an enterprise view, if you are looking at enterprise view, you have to work with all the systems. Suppose if you are CEO or CFO of the organization, and I need to look at my organization in its totality, then what will happen is I will have multiple systems talking to me. I will have sales system. I will have HR system talking to me, right? I will have marketing system, marketing department, risk department, and all of them have their own system and processes, right? Now I don't get one view of all the departments. And if I were to give out this task to somebody to create that one view, they would have to go and understand all the systems. They would have to understand the appropriate linkages between the systems, and they would have to then create that particular view. So all of this is solved by your data warehouse. So that's why data warehouse is needed for us. Now, is it clear for you guys what data warehouse is? This is all about your data warehouse. Do you have any questions in data warehouse? Anyone? Yes. Can I get more response? I only got 2 or 3 response. You just sit back and relax. We are just discussing theoretical perspective of what data warehouse is in today's session. So there will be no any complex task for you in this session, right? So if it is clear, if you don't have any question, we'll go to next part, which is structure of a data warehouse. Now, as we have discussed, I am going to discuss this uh, facts and okay, where is that? Truth and facts. As I have discussed, to allow me to discuss to explain this after some time. Now it's time to discuss this facts and truth. So in the previous segment, you learned about basic concepts of data warehousing. Now, one of the primarily method of designing data warehouse is called as dimensional modeling. So you got an idea about the data warehouse, but what about dimensional modeling now? What about dimensional modeling? So the two key elements of dimensional modeling include facts and dimension. Right? Now suppose you're interested to design our database. It should not be any random design, right? So these two key elements of dimensional modeling include facts and dimensions, which are basically different types of variables that are used to design data warehouse. They are arranged in specific manner known as schema diagram. Then now we are going to discuss the schema diagram. So imagine you are working in an organization like Flipkart or Amazon, and you're asked to identify products in electronic segment that are non-profitable in rural Uttar Pradesh, let's say. And you have to test if this is due to high cost of transportation. You have to access the sales database for that. From various districts, various product information, from product table, right? Or order information, which includes uh, which can include the means of transportation, use customer management system database, and many other such database we can have to just analyze this. So we have sale database, product database, order database, and customer database. Now, how will you proceed, right? How will you proceed to analyze what was the problem statement? To identify products in your electronic segment, in your electronic segment that are non-profitable, basically. That are non-profitable in this rural Uttar Pradesh. So how will you proceed? This session will teach you exactly what you would do to answer such questions before data can be loaded into data warehouse. Before data can be loaded in data warehouse, we should we first need to create appropriate structures for storing the data. By structures, we mean what should be the tables, what should be the columns, and what should be its data type, and so on, right? So it's not that easy as it looks, right? This process is called design of data warehouse. We'll now talk about specific design techniques, and this is known as dimensional modeling. design technique is known as dimensional modeling. These are dimensions and the facts. The two key elements are dimensions and facts. And let us talk about facts first. What is mean by facts? A basic numeric data we want to analyze is a fact. In general, numeric attributes are called as fact variables. Let's say in our investment data, in our investment data, the investment amount is an example of fact variable now. And you can look at the any data out there, and you can segregate what is fact variable, right? So here amount in US dollar is a fact variable in a company data file, investment file, and correspondingly you can just segregate the fact variables in your data. Now, I hope you are with me till this point of time. Facts are known as basic numeric data. So you take any database out there and you'll be easily segregate out what is fact, right? Now, let us talk about dimensions, dimension variables. The dimension variables add life to the fact variable. What I mean by this is that dimension can be used as the basis for analyzing fact variable, basis for analyzing fact variable, uh, or basis for analyzing fact variable or fact data. In for example, a dimension variable is the information of company being funded, right? It is an information about the company being funded, or date, or country code, right? This is known as dimension. uh, so name over here is a dimension variable, date is dimension, and country code is dimension. You can see that without this dimension variable, the fact variable are meaningless. Yes or no? Without name of this organization, the amount only I have, it is meaningless. What analysis can you do with big bunch of numbers without having any additional information about those numbers, right? So that is why fact dimension variable can be thought of as metadata corresponding to the fact variable. It is metadata corresponding to the fact variable. Several dimensions attributes, for example, company permanent link, name, sector, country code, state code, region, city, along with all their values, make up the dimension table, right? Fact table will have only numerical column. Dimension table will have metadata corresponding to the fact variable. Now, what it means is the analyst can choose any of these attributes to initiate analysis. And I may want to analyze the investment on the basis of sector, or the state, code, or even the city, right? So this is known as a basic of dimensional modeling, which we have discussed, right? Now, once you have an understanding of what data warehouse is, how the structure of data warehouse is, we should start with the star schema. So consider uh, uh, a typical problem. You might involve multiple database with many different variables, but we may not be interested in all of them, right? Hence, only some facts and dimensions are combined in specific manner to build the structure of a data warehouse, which is called a star schema or schema diagram. So a schema is an outline of the entire data warehouse. It shows how different data sets are connected and how the different attributes of each data are used for the data warehouse, right? Now, we'll see an example of how e-commerce company can design their data warehouse. We'll see an example of how e-commerce company can design their data warehouse. So let's say we have date of purchase, we have product, we have customer, and we have quantity, right? So on 5th Jan 2017, product purchases, let's say pizza, purchased by some John, quantity is 2. Again on 5th Jan, or let's say 6th Jan 2017, Coke is purchased by again some John, and the quantity is 5. Again, we have something, so we can have multiple entries in this data, which you can mark or which you can consider, right? So we have date, we have product, we have customer, and we have quantity. Yes or no? So, uh, so this is the schema to begin with. You say, what kind of analysis can I do? I can find out in all how many products did John purchased, so I can identify John from this customer table, and then I can total it up, and they say, and they then I can say, I'll join purchase with this monthly quantity which is purchased by John, right? So this is good enough to do certain types of analysis, certain amount of analysis, right? Of course, I can find out. Just tell me what is the total quantity that was purchased for each product, right? So how much pizza was purchased, how many cakes were purchased, and so on. So when I want to summarize this particular information based on this information alone, there is a certain number of reports I can create, right? But it is definitely not interesting. Suppose I want to ask the question, let's say, what do people from particular city, let's say Bangalore, purchase in general? If I look at this particular database, that information is not here, right? Suppose I wanted to analyze how many customers have purchased pizza from Bangalore, right? I If I look at this particular database, the information information is not here. In general, what is soft drink sets? If I look at this once again, there is no information generally what is very hot during weekends, right? Second question is, I cannot analyze what is trending product which is sold on particular weekends. Well, we look at that information is not here either. So this task schema is essentially useful for augmenting your main data with additional information that is useful for our analysis. So let me develop the schema for you, right? We talk about products. So what can I say? Merely name of product is not good enough, right? Because for all, the name of the product will not be generic as pizza. It will probably say that specific flavor, specific size, that for that particular product, right? For example, regular veggie lovers pizza without any toppings or without two topping is one specific product, right? So what I want to do is I want to augment it with personal information. So I say all that information about the product is captured in a separate table. And so here I will say the name of the product, the category of which the product belongs to. And so is it for food product, or is it electronics product, or not all kinds of categories, right? Uh, I can have lots of information about the right similarity with customers of course, I will have the same, I will have the name, but then I will have city to which they belong to, the category of which of the customer you may not have realized, or the date itself can be quite interesting, right? So it's just not 5th January 2017. In addition to that itself, I will say the day of the week, right? Is it holiday or is it weekend? So all the information for each date, I will store it separately, right? Now, what you can see is slowly what is getting developed is looking at a star, right? So in a star schema, a central, there is always be fact at the center. There will always be a fact at the center. So let me help you out with that. Date, product, customer, and quantity. Then I have product over here, in which I can have name, I can have category. I have customer over here, customer table, in which I can have customer name, customer city, customer category. I can have date over here, and I can have various attributes to that, right? Or day, basically, is it on which day, Friday, Saturday, something like that? Is it holiday or not? And something like that, right? Now, so if you observe, this is getting developed like a star, right? It is getting developed like a star. If you just join this with this with this, and this with this. So it is generally developed like a star. So that's why it is known as star schema, right? That's why it is known as star schema. So in star schema, basically, there's central table, central fact table. Always and always we will have central fact table, and surrounded by dimensions. So if somebody asks you what is there in what is star schema, you should remember central there is always a fact variable or fact table. And what is fact table? What is fact variable? What do we mean by fact variable, guys? We just have discussed, right? What is fact and what is dimension?
Fact is a numeric
Variable.
values.
Mhm. Yeah, right, right. And dimension is metadata, which explains the numeric variable, that is fact variable, right? Now I'll help you out with one document, even though that is not uh, restricted to our syllabus, but you can read that to understand what are the different uh, star schema or schema that you have, right? This is totally related to software testing people out there or data engineers. So schema types in data warehouse modeling, star and snowflake schema. You can read this article, which is published by this guy on 7th March 2024. So we have star schema, snowflake schema, galaxy schema, star cluster schema. This is not required for data scientist people out there. But if you want to have a good read about that, you can discuss. You can read this. Now, if you see here, this is central part is always a fact variable, which I have discussed. What is fact? It's a numerical. Sales ID is numerical. Customer ID is numerical. Product ID is numerical. Data ID is numerical. Store ID is numerical, and sales unit is numerical. Yes or no? So remember, central, there will be always and always fact variable on on your in your star schema. In your star schema, there will always and always a central fact variable surrounded by dimensions, right? So I'll just share this article with you if you want to have a look at this. You can read this, which is something extra when it comes to a syllabus, right? So you can go through this for your data uh, warehousing or something like that. You can read about this to get an idea about that. Now, I think we can stop here for the day. Again, whatever we are going to discuss is simply a theoretical one. So let us not go with that. And also, we don't have time left with us. We'll stop here for the day. In the next session, we are going to discuss OLAP and OLTP, which is basically a difference between data warehouse and database. But that is a wrong question to ask. We call it as a wrong question. You cannot distinguish data warehouse on database based on its characteristics. We call it as online transactional processing and online analytical processing. So one is known as data warehouse, one is known as database. But the question is, what is the difference between online transactional processing (OLTP) and the difference between online analytical processing (OLAP), right? So we'll discuss that. Then we'll discuss select, extract, transform, load, and then constant, and then we'll start with the SQL part. So I think still we'll require Sunday to cover SQL and probably one or two more sessions to discuss more about the SQL, right? If we have to discuss more practically or in more detailed fashion, right? So let us see. Anyway, the lectures is not fixed. Like they have given us some leverage to extend the sessions and its quantity. So we have plus point for that, right? We can discuss that. All right. Now, I think you guys will require this Excel file, which we have discussed, right? So I'll just save this and I'm going to share this with you on your drive. Okay, drive link you guys want, I'll just share. Just a minute. Yes, meanwhile, if you have any query, if you want to discuss anything, if you have any questions, you can ask. Yes, guys. Do you guys do you have anything to discuss? All right, so I've posted this, and I think handling missing data is also something which you guys will require, right? Anyway, I think I've given that on your drive. Is it? No. Hmm, I think it's not shared. No. Today is day 11. Is 9th November. And I'm sharing the SQL file and uploading the data cleaning. So, hmm, okay, right. This is all right. Now, your drive link, make sure you bookmark this, guys. Don't ask it again and again. You should have this for your study. Sir, I have an issue with one of the code. Can you help me with that? Yes, you can share your screen. Yes, Darshini.
Yes, sir, I'll share. Sir, can you see my screen, sir?
Yes.
When I'm running this code, sir, I cannot get the output. It's showing type error, sir.
Okay, scroll down. Aggregation function failed. How is equals to mean? Okay, scroll up. Right. This thing, everyone will get error for that.
Okay, sir.
So how do we handle? I have an alternate code for this.
Okay, sir.
Just a minute, I'll just check that. So again, as I told, there are some discrepancies related to your uh, version of Jupyter Notebook, right?
Yes, sir.
Depending upon the
Yes.
version you use. So I think I have done this in the other classes. I have that. Mhm. Can you just share your screen? It's already shared, no?
Yes, sir.
I'm unable to get that right now.
Okay.
Just a minute. Just a minute. I'll just take control. Hmm, where is that? Earlier we had an option to take control, screen control.
Oh,
Uh, Okay. Can you just search that error?
sir, okay, sir.
Not that below.
Okay.
Error line is at the end of. Okay, just a minute. Just a minute. Aggregation function failed. How is equals to mean data type is object. I know we had done something for this. Scroll up little bit. Location. There's another alternative function, man. Can you just restart and run all this?
Okay, sir.
Just-
I'm still getting that errors.
Hmm. Okay, remove one thing. By is equals to, remove that. By is equals to. Remove that
Okay, sir.
and run this. Remove extra square bracket which is there. Now run this. Still we're not getting.
No, sir.
Okay, let me check with this. I'll get back to you with this in tomorrow's session. See, I'll
Okay.
if I just share my screen, just a minute.
Okay, sir.
If I have to share my screen. It is in operations on data frame, no? Which file is that? Yes, Darshini. The file which we
It's on 27th, sir.
27, no? Okay.
Yes, sir.
See, can you see I am getting the same thing. If I restart and run all this, I'm getting this. I'm not getting the error, right? If you do here we have, no?
Yes, sir. I
Okay.
tried that as well, sir, but for that also I didn't get the output.
Right. Data.info. Okay, we have an alternative which is very vague. What we can do is uh, location wise mean you want, no? Location wise mean.
Yes.
So you read data as okay, data.head is this one. So you read and you write an index underscore call is equals to 1, right? So basically you read data, pd dot df is equals to pd dot read underscore, what is that extension? File. Is it Excel? Pd dot read underscore Excel. You read the data, sales, and you write on df dot. Okay, here you can write on index underscore call equals to 1, and you write on df dot head. This is region, is it? Okay. So the data is weather data. But read underscore CSV. So here we write an index underscore call is equals to 1. The location and location wise mean you want, no? So you can do like this. So basically filtering the data out based on the location like this, if it is not working.
Okay, sir.
As of now, you can do that. But we have one alternative function which I'm not getting right now. We were getting the same error in the other batch. So for that, we
Okay, sir.
all right. All right then. Thank you.
Thank you, sir.
Yes, guys. Do you have any questions? Others? All right, then I'll take silence as a no. We'll stop here for the day. Uh, if you have any questions, you can ask in tomorrow's session. You go through this basics concepts of data warehouse. We'll discuss the same. We'll continue that in the next session, right? Sure. All right, everyone. Thank you. Happy learning. Bye.
Thank you, Vipul.
Thank you, sir.
Thank you, Vipul.
Thank you, Vipul.